Okay, so the next topic that we're going to do is multiplying, dividing, adding, and subtracting rational expressions. I did do it with some of you guys this year, but I remember when we had gone through it, it was a little confusing when we were talking about rational expressions versus rational equations. So you do have to know how to do all this in pre-calc. You're going to go over it, so I figured we might as well move on to this next. A rational expression, the definition of that is just a fraction in which the numerator and denominator well, it doesn't have to be both. So numerator and or, we should really say, and or denominator are polynomials. A fraction in which the numerator and or denominator are polynomials, also known as an algebraic fraction. Okay, we actually did talk about them, we talked about them earlier in the year. We did simplifying them, and we also talked about when they're undefined. So this is an example of what we did early in the year. So this first example, 3x plus 6 divided by x squared minus 4, this is a rational expression. The numerator and denominator are both polynomials. What we did before was simplifying them. So if you remember, to simplify them, you factor the top, factor the bottom, see if they have anything in common, and if they do, you cancel them out. So 3x plus 6 is really 3 times x plus 2. And x squared minus 4, you can factor using the difference of two squares. You get x plus 2x minus 2. So the x plus 2's cancel out, and you're left with 3 divided by x minus 2. These two things are the same thing, it's just that 3 divided by x minus 2 is more simplified. Kind of like if you have 5, you don't have to write this, but if you have 5 over 10, if you simplify 5 over 10, that's 1 over 2. They're both the same thing, it's just the 1/2 is simplified further. Okay, if we look at the second example, 5 minus x divided by 2x squared minus 50. If you factor you can't factor the top at all, but if you factor the bottom, first you would take out a GCF of 2, and you're left with x squared minus 25. And then you could factor x squared minus 25 further, so you get 5 minus x divided by 2. That would be the difference of two squares. Again, x plus 5, x minus 5. The x minus 5 and the 5 minus x will cancel, but because they're opposites, they're flipped around with a subtraction in the middle, they cancel to be a -1. So this expression simplified is -1 divided by 2 times x plus 5. You don't have to multiply that back out. Okay? So before we get started, you really just should remember that x plus 3 and 3 plus x, those cancel right away because addition is commutative. You can switch them around. But x minus 3 over 3 minus x would cancel, and you'd be left with a -1. If they are opposites and you have subtraction in the middle, they cancel to be a -1. All right? So your steps, what we're going to do today, we're going to practice multiplying rational expressions. You have 3 steps. Your first step is to factor the numerators and denominators completely. Factor everything completely. Second step, you're going to cancel the common factors. Kind of like what we just did. Cancel common factors. And you can only cancel a numerator with a numerator and, a numerator with a denominator and a denominator with a numerator. It has to be switched. Okay, you cannot cancel a numerator with a numerator. Kind of like if I give you this. If I gave you, let's say we wanted to multiply 2 over 3 times 12 over 5, let's say. You cannot cancel the 2 and the 12 out, okay, to be 1 and 6. You would cancel the numerator with the denominator. This would be a 1, this would be a 4, and you would get 8 over 5, okay? But that's neither here nor there. Okay. And your third step is going to be to rewrite the product as a single fraction. Now you don't actually have to multiply them out. You can just write them next to each other, okay? So again, the whole purpose behind this video is to multiply rational expressions. It is not to show you how to factor, right? That's why last week we did a whole bunch of factoring. So when I go through this, I am not going to factor out each one for you. I'm going to show you what it is factored, and then from there, you're going to see what the new thing is, okay? The new steps. So for number 1, we have 12x over x plus 5 times 5x plus 25 divided by 6x. So I'm going to factor everything. If you want to do that on the side and make sure you get the right answers, and that's fine too. 12x factored, can't do, it's 12x. X plus 5 factored is x plus 5. Can't do anything with that. Times, this one's actually pretty easy. To factor 5x plus 25, you would do 5. Take out a 5 as a GCF, you are left with x plus 5 divided by 6x. That's your first step. You factor everything. It just so happens that in this case, the only thing that had to be factored was the 5x plus 25. No big deal. So now we're going to cancel things out. So the x plus 5 cancels. The x and the x cancel. Then the 6 and the 12, you could pull a 6 out from each. When you do that, the bottom turns into a 1 and the top one turns into a 2. So then you just rewrite everything multiplied, okay? So you have 2 on the top, you have a 2 and a 5, and on the bottom there's nothing, so it's really a 1. So on the top, 2 times 5 is 10. So this expression up here is really equal to 10. No matter what you plug in for x, it's going to simplify to be 10. Number 2, factor everything and then see what you can cancel out. So when you factor x squared minus 6x plus 8, you should get x minus 4 times x minus 2. Again, you're going to have to do that on your own. I'm not going to factor for you now. And then we have 3x minus 6. You take out a 3 as a GCF, left with x minus 2, times 7 divided by 4 minus x. So the x minus 2 and the x minus 2 cancels. I'm going to change colors here just so you can see. X minus 2 cancels. X minus 4 and 4 minus x are opposites, so you replace one of them with a negative 1. I like to always replace the top one with negative 1, but it doesn't matter, okay? On the top, you are left with a negative 1 times 7 is negative 7. On the bottom, you just have 3, and that's your answer. You could have a polynomial, you can have another rational expression, I really should say, as your final answer. It just so happens that in 1 and 2 you get not integers, you get rational numbers. And then number 3, you can also do this with 3 things going across. You could have 3 rational expressions being multiplied. The rules don't change. You cancel a numerator with a denominator and that's it. So 2x squared plus 5x minus 3, when you factor that, that should be 2x minus 1 times x plus 3 divided by, on the bottom, 10x. Can't factor that. Times 10x plus 5. Take out a 5 as a GCF, you are left with 2x plus 1. Divided by x squared minus x minus 12, that's master product. Should end up with x minus 4 times x plus 3. Times 16 minus x squared. Remember, whenever you're factoring and you're doing the difference of 2 squares, you do the square root of the first number, that comes first. So the square root of 16 is 4. Square root of x squared is x. 1 plus, 1 minus. And then you can do the difference of 2 squares again on the bottom. Square root of 4x squared is 2x. Square root of 1 is 1, so you have 2x plus 1, 2x minus 1. And then we're going to see what we can cancel. You can cancel things from the first fraction all the way to the third, but again, it has to be a numerator with a denominator. So this 2x minus 1, this 2x minus 1 will cancel. 2x plus 1, 2x plus 1. X minus 4, 4 minus x. They're opposites with a minus, so that's a negative 1. Then you have x plus 3 and x plus 3. You also have this 5 with this 10 would become a 1 and a 2. And that's it. So on the top, you are left with a negative 1 times x plus 4, or 4 plus x, doesn't matter. Again, addition is commutative, so if you wanted to flip them, you can. And on the bottom, you have a 2 and an x. And that is your final answer. Okay? Make sure you submit your notes, homework. There's a few questions. I think there's 4. You will get tomorrow. Let me know if you have any questions. Have a great day.